Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized pieces.
Today, we're tackling a problem that anyone who's ever tried to read a doctor's prescription will understand: bad handwriting. But we're going a step further. Imagine teaching a computer to read messy handwriting not just in English, but in completely different scripts like Arabic and Persian.
It's a massive challenge for artificial intelligence, but a new paper proposes a wild solution. What if we used an AI to build another AI that's perfectly designed for the job? It's like hiring an AI architect to design the perfect handwriting reading machine.
Exactly. The paper is called LLM-Driven AutoML for Cross-Lingual Handwritten OCR, which is a mouthful, so let's unpack it. The goal is to automatically recognize handwritten characters, which is what OCR, or optical character recognition, is all about.
And for years, this was a painstaking process. Experts in machine learning would have to sit down and manually design what are called neural networks. You can think of a neural network as a computer's version of a brain, with layers of digital neurons that learn to recognize patterns.
The problem is that designing these brains is incredibly difficult. An expert might spend weeks or months trying different layouts, tweaking settings, and hoping to find a design that works well for, say, English. But that same design might be terrible for Arabic because the characters and the way they connect are completely different.
It's slow, expensive, and doesn't scale. So the researchers behind this paper asked a brilliant question. What if we automate the architect? What if we use one of today's powerful large language models, or LLMs, the same technology behind tools like ChatGPT, to be our designer?
And that's exactly what they did. They created a fully automated pipeline. It's a closed-loop system, which sounds technical, but the idea is actually very simple and elegant.
Let's walk through it. Step 1, the researchers take a dataset of handwritten letters, maybe in Persian. They feed it to an LLM, like GPT-5, and basically say, hey, here's some handwriting. Your job is to design a neural network that can learn to read this. Give me a blueprint.
The LLM, acting as the architect, then outputs a detailed blueprint for a neural network. This isn't a drawing, it's a file with precise instructions, like a recipe, specifying every layer, every connection, and every setting.
Step 2, a computer system automatically takes that blueprint and builds the neural network. Then it trains it on the handwriting samples, letting it practice until it gets good at recognizing the characters.
And here comes the most important part: the feedback loop. After the model is trained, it's tested to see how well it performs. The system measures its accuracy. Did it get 80% right? 90%?
That score is then fed back to the original LLM that designed it. The prompt is now something like, okay, your last design scored 92% accuracy. That was pretty good, but can you do better? Give me a new blueprint.
It's like a chef trying to perfect a new recipe. They bake a cake, taste it, and then decide to try again with a little more flour or a different baking time. Except here, the chef is an AI, and it's learning from its own successes and failures, getting smarter with each attempt. For this paper, the AI did this 30 times for each language.
So what happened when they unleashed these AI architects on the problem? They tested 3 different LLMs for the job: GPT-5, GPT-4o, and Claude Sonnet 4, and had them design models for English, Arabic, and Persian.
The results were fantastic. This fully automated system, with zero human guidance on how to actually design a good model, consistently discovered architectures that were highly accurate, averaging over 93% correct. They were also fast enough to be used in real-time applications, like digitizing a document as you scan it.
What's really fun is that the different AI architects had distinct personalities or design styles. GPT-5 was the minimalist. It consistently created the smallest, most efficient models that still performed really well.
GPT 4.0 was the balanced all-arounder. It created models that were a bit larger than GPT-5's, but it often achieved the highest average accuracy, especially for Arabic. It was a great, reliable choice.
And then there was Claude Sonnet 4, which you could call the maximalist. It consistently designed huge neural networks, sometimes with 10 times more components than the ones GPT-5 came up with. But despite their size, they were still very accurate.
And here's a fascinating little detail. Even though Claude's models were massive in comparison, they weren't really any slower. This suggests that for these AI models, speed is more about the complexity of the design, how the data flows through it, than just the raw number of parts.
So, what's the big takeaway from all this? This paper isn't just about reading handwriting, it's a proof of concept for a new way of building AI. It shows that LLMs can be more than just chatbots or creative writers. They can function as autonomous engineers, solving complex design problems.
This is a huge step forward for a field called AutoML, or automated machine learning. The dream of AutoML is to make creating powerful AI systems accessible to more people, not just the handful of experts who know how to build them from scratch. This work makes that dream feel a lot closer.
Imagine being able to create a custom AI for any task, for any language, just by describing the problem and letting an AI architect figure out the rest. We could rapidly digitize historical archives, develop tools for students with learning disabilities, or build systems that can understand any script in the world.
It's a powerful idea, and this paper shows it's not science fiction. It's happening right now.
And that's all the time we have for today. Thanks for tuning in to Daily Papers.
Join us next time as we break down another exciting piece of research.